Hello, everyone. Welcome back to another episode of the Engineering Side of Data. I'm joined by Sven, and we're going to be talking about functional data engineering. Sven, please introduce yourself.
Yeah, thanks, Bob. Thanks for having me. So I would call myself a data practitioner. I'm currently a data product owner, and I research a lot about data and how people build data companies and use data, build data stacks, and I write a lot about that. So that's what I'm basically doing.
Yeah, and folks, when Sven says he writes a lot about that, he is telling the truth. He has a great blog, an excellent newsletter. I believe it's called 3 Data Point Thursday.
Yeah.
Check that out. A lot of good content coming from Sven on functional data engineering and a host of other things that he talks about. And is a great follow on Twitter. All the links to blogs, newsletter, and his Twitter handle will be in the show notes. All right. Sven, thanks for coming on. Let's dig into some of the questions I have for you. What is functional data engineering?
Yeah. So the not yet completely defined is probably the best way to say it. So Maxime, the founder of Airflow and Superset and our creator of the company called Preset, he came out with this kind of landmark article, I think 2018, which is called Functional Data Engineering, where he described an approach to doing data. He's been seeing at a bunch of big companies and also himself implementing. And that basically just they were taking ideas from functional programming and transferring them to the data engineering world to mostly increase the reproducibility of what they were doing. So that was his idea, and I was kind of like actually trying like in the last couple of weeks to actually extend this a little bit, because Maxime also realized, this isn't the end. It's not just about reproducibility. Actually, bringing these ideas from functional programming to data engineering can do lots for reproducibility. Of course, it's like when your manager comes to you and says, "Hey, by the way, this report looked very different yesterday, and the data from the past shouldn't change." That's kind of like you're like, okay, so there's new data and new code, and I have no idea what went wrong. So that's reproducibility, being able to actually go back in time, see both the old data and the old code, and then being able to reproduce the report as it was, for instance, yesterday or a week ago or a year ago. But then, when your manager comes to you at that point in time, you kind of want to, the first thing I want to do is like roll back to a working state. Okay, so in that point, it's actually something very different. So I don't want to wait 2 hours to reproduce, like yesterday's report. I kind of want to be able to dispose of it, like dispose it, roll back to the last working change within like a couple of seconds or minutes, So there's the idea of like kind of like disposability, which is it is called disposability, and I think the infrastructure as code world, but it's still an idea from functional programming. Yeah, and then while you roll back, you actually still want your business intelligence tool, your Tableau, whatever you actually want it to keep on working. So you also want to have the service continuity. It is called when you fix your problem, you want to be able to actually test it completely. So like testability is another thing these ideas help with. So there's a bunch of goals actually. I identified like 5 ones, which I really like, which are really helped by these functional programming ideas. Sorry, I lost track of your question.
Oh, no, that's all right. Yeah, that was a very broad one. It just, what is functional data engineering? And you described some of the goals there: reproducibility, the ability to test. Those are the 2 big things that I associate to functional data engineering. What are some of the, I guess, let's get into some of the concepts around functional data engineering, like pureness, idempotency, all those things that people may have heard of, but don't have a good grasp on.
Yeah, let's do that. So what I've identified that Maxime has been using, and that I also would talk about as very useful ideas are 4. I think when we started, to chat, I only had 3 down. So one is pureness. Okay, pureness of in functional programming is a function. In functional data engineering, we would usually take like a whole DAG or like a job or something. The stuff we tell the transformation, the DBT model, whatever. The units we have. So we want this to be pure, and that means something very simple, like same input, same output. It's as simple as that. But in the data engineering world, if you think about it, if you have like a daily job that runs, every day, it kind of produces something different every day. So that actually doesn't have like the same input, which is like start. It kind of always has a different output, which obviously makes it hard to reproduce stuff. Okay, so the pureness is one very important part. Then we have idempotency, meaning that we, if we have to hit the transform button like twice, we should still get the same result. I mean, of course, we should still get the same result, but you probably know as well, very often we actually get a very different result when we run a transformation twice. So like new stuff, for instance, coming in, old stuff, or like new and old stuff kind of breaking. So that's idempotency. Then we have immutability. So our function, produces something as an output. Okay, and this output is can be like an object, a struct, like a data set, whatever. This thing we have, and that we should treat as immutable, meaning this thing should not change ever once it's produced. So that sounds like a weird idea, but the point simply is, if I have a data set, immutability means when I want to change something, I get a second version of it, but I can still access the first version. So this thing, it's the same if I have objects. I can still have objects in functional programming, right? But they just, I have like different versions of objects and I can access them all. So that's the idea. So I get kind of like auditability or traceability of what changed. So that's kind of the idea. And the fourth thing I realized is really important is single responsibility. So single responsibility kind of means my unit I have should only do one thing. Okay, it shouldn't do 2 things. It should just do one thing. And the whole point is, because it's just does one thing, it actually is much easier to make it pure and to be able to test it. The weird thing about like single responsibility is it's really hard to understand. There's no good criteria. The one criterion I always use is I know it when I fail. That's when I want to touch when I want to touch a function, and I realize I only want to change one half of it. I realize, okay, I just want to change one half of it, but if I change it, it's hard because it actually does 2 things. But I just want to change this one thing, and if I just if I change it, the whole function, there's one half of this whole function, I have to adapt all the tests for the whole function, even though I just want to change one part. And that's the point you realize, I actually, this actually shouldn't be that. This one half should probably be a separate part. So these are like the 4 ideas that have. So Maxime also identified them actually in his post. I don't think he calls them out, but he definitely works with them like as core ideas. And these are really like helpful to achieve these, like using these 4 ideas alone, you can actually achieve these goals we've been talking about in the beginning.
Yeah. I remember that article when it came out. And I believe you're right. It was around 2018. Yeah, there's 2 big articles I think of when I think of Maxine. One is that functional data engineering one, and the one that preceded it was the what is a data engineer, or the rise of the data engineer, I believe it was called. To talk about a lot of in fact I believe he coined the term. So 2 pretty impactful blog posts there that definitely would recommend that to read if you haven't already. And that single responsibility, that's I guess I never really attributed that to functional programming, but that does make sense, and definitely a worthy goal for testing and general understanding. And I do think, that's. I think people think of functional data engineering, and at one point I put myself in this camp that it seems like it's makes things more complex than it needs to be, but in reality, it's all about reducing the complexity. Yeah.
It's actually a great point. Because I talked to an author like a week ago. It was called Jonathan Sharvit, I think, and he's been writing a book called Data-Oriented Programming, actually. But he's diving really deep into this complexity theme, and he's also making it's a short excursus like data-oriented programming. That's actually for for software engineering side of things. Mm-hmm. But the idea is there that you actually separate kind of like the code, the objects from the data they hold. Kind of so it's kind of the idea that you would have like a separate data object for
abstraction of
things.
Yeah, okay.
Exactly. And the whole point he's making is this is actually much simpler because you turn from like one UML diagram where we have like maybe 4 different entities, they hold code and data together, and like lots of different dependencies, to 2 very simple ones. Now you might end up with like 6 to 8 entities, so like more stuff overall, but they are separated, and the individual pieces are for humans much easier to understand. So the question, and I kind of think of functional data engineering as reducing the complexity in the same way. You will get parts. The individual parts will be much easier to understand, even though you might actually end up with like more parts. Maybe there are less dependencies, so that if you have to look at like what do I have to fix. I always ask myself, like, what do I have to understand to fix something? It's kind of like my metric, like to improve something. And there it's, with functional data engineering, this part will be very small. Okay, so the very small part you will have to understand. Even though if you want to touch like everything, you might actually need to understand more. If you want to improve something or fix something, this is actually much easier than in a world where you do not do that. So the complexity in that sense, the understandability is improved.
Yeah, absolutely. Yes, I think the ability to understand things easier, that's certainly a goal or a byproduct of functional data engineering. And then you've mentioned this during the conversation already, but that ability to unit test as well, right? If you're having difficulty how do I come up with an effective unit test for this function? Perhaps that's where you can maybe a cue to look into functional data engineering and follow the principles that you mentioned. So yeah. Yep.
Yeah, like if you want to do an example, because I just thought about one. Like take for instance, if you have like I don't know, like a DBT transformation, which takes like raw orders on the one side, and transforms them into some kind of aggregate. For instance, like I don't know, like the order count or order volume per month. And you might have like a second information inside the orders, like an order status, like having like a 1 for it's ordered, 2 for it's shipped, 3 for it's been returned, and 4 for like some canceled order. And you might, like what I would do like in the beginning is like to have like one transformation, and I would probably map these numbers to their speaking names, and I would do the aggregation, like one thing, and I would run that, and I would probably write a test for that, and so I'd be happy. And then like this actually happened to me. Like a week later, I will realize it's not just numbers 1 to 4. It's actually there's also a 5 and a 6. So I gotta change something. But I just gotta change one thing. Like one part. I don't actually want to touch the aggregation part. I just want to have this mapping. I just want to change this mapping, and I probably don't want to even test like whether mapping works. I just want to have like a test whether all, I actually have all the numbers in there. And that's actually probably kind of hard to do in like this big transformation. So there's the point where I would realize, I probably violated the single responsibility idea. I should probably pull this, this mapping just out of there, just have like a join with a mapping table, and maybe put the, like if I have DBT, I would probably put the other thing as a DBT seed inside some, just a CSV file, for instance, which would also mean it's versioned, and add a test there. So that's kind of like my approach to that, and I think I kind of like this pragmatic idea. I'm guessing, like I want to introduce. I don't want to introduce like functional data engineering like from the very beginning into my workflow. I want to use it whenever I encounter a problem. I want to start with this huge monolithic thing, ugly thing, and then when I get a problem, then I want to start doing these cool things.
Yeah, that's you. So you just mentioned DBT, which I think that also people may associate functional programming to maybe more traditional coding, Python or Scala, Haskell, things of that nature. But you can even follow these principles and other things that may not be readily apparent, like DBT with SQL, right? That's that's pretty interesting. Yeah.
Yeah, of course. And I did actually ping Maxime about that, because at preset they're actually using DBT, not this huge data lake machine he's been using before. So he's actually doing that at preset, and what they're doing, I think he describes it pretty simply, like on. So they're kind of like also using the DBT built-in snapshot features, but they're kind of like doing like a cross join with like a timetable, meaning like on every single like run, the new kind of like valid version of the whole tail is created. So you can actually even do that in DBT. And this DBT seed feature actually works really well for like pulling out these these singular responsibilities. So you do have so DBT, I would say, is actually like a good tool to use these ideas.
Yeah. I remember that. I remember seeing a talk that he gave, and he spoke a lot about snapshotting dimensions. He really drove that point home, and it made a lot of sense. I think his main argument was, hey, storage is getting cheaper, will continue to get cheaper, and dimensions are never as big as relative to facts. So snapshot them and then join. It's just such a novel concept that I think at first is like, this is crazy, but then maybe over time it's like, this makes a little bit more sense. So
yeah, by the way, to like keep on staying on the DBT version of that, I hope people can understand that. But I'm going to try to describe one thing. So if you do that inside DBT, if you have like an SQL based database and you actually snapshot all your dimensions, meaning like for example, like a dimension for the customers, and you would probably like put in like a new valid version of all customers each day. Okay, so that means like from this table I can select my like current valid customer dimension, but I could also see like which ones were there yesterday, which were then the day before, and so on and so forth. Now the cool thing in DBT is that you can actually use macros. So for instance, you could like write a macro which delivers me the latest customer dimension. So I wouldn't actually even have to worry about that. I can just use like a macro which points me to the most recent customer dimension. And the even cooler part is, if something breaks, I can roll back just by redirecting the macro, which takes like 5 seconds. So if you break the new customer dimension, you can roll back like everything that worked, just like with a single point, which gives you like the latest timestamp, the latest customer dimension, just by like replacing one value. So that is pretty cool. Wow. I think
that's pretty effective. Yeah. Well, Sven, you must be the most technical product manager that I've ever come across. Sounds like you.
Thank you.
Get your hands dirty. I like it. We've touched on this a little bit. Oh, what's that?
No, sorry. Yeah. Well, I mean, I actually find it hard to not touch the fun stuff.
Oh yeah. Yeah, absolutely. Yeah, it's not. It can never be a downside, right? I mean, to have that knowledge, right? We've touched on some of this a little bit about why aren't more people doing functional data engineering, and we spent a little time discussing maybe the perceived complexity. But are there other factors? Why when you give your pitch for functional data engineering, what kind of pushback do you get?
So I think I just watched like a talk by Jess Humble, which has been a couple of years old, but his stuff is great. He's doing this continuous delivery stuff. And what he says there for the software engineering side of things is it simply is too hard. Okay, it simply is freaking hard to actually do these practices like the high performing teams. Like high performing teams, I mean like the like top 5, top 10% do. I think it's very similar in functional data engineering. If you're talking about like doing this, it actually takes not an experienced individual, but like an experienced team. Like really experienced team, which is which goes on into this journey of like jumping over a bunch of hoops to make this work, and it simply is hard. I think that is the point. It simply is hard. I think though, like to listeners, by the way, the better question I think is like, why aren't you doing that? Because like as an individual, you can actually start doing these little things. Like understanding single responsibility, going about the testability, the pureness of stuff. You can most of these ideas you can apply like in kind of like an atomic way. Start moving towards that and then use that to convince people. That's what I usually try to do.
Excellent point. Yeah, this isn't an all or nothing proposition. The principles you've mentioned, if you can achieve idempotence, make your functions pure. Again, it's not an all or nothing proposition. And I think that's what I think people think that, hey, I have to I have to follow all these principles to be successful. And I'm dealing with data. Naturally, we're going to have side effects. I can't do it. And I think that's one of the reasons why I like you put out a GitHub repo called Easy Functional Data Engineering. And I think that illustrated that quite well. He said, hey, we have this problem. We have impure functions. We have functions that mutate objects. We don't have idempotency. Here's how we can achieve 85% or 90% of a functional approach, and we do the best that we can where we can, that type of a thing. What was some of the
trying to get the word easy in there?
Yeah, there you go. Yeah, no, I think that really drove home a lot of points, and I refer people to that repo when the discussion of functional data engineering comes up. I guess that's probably the motivation behind it, right? Was to come up with an example of all these concepts, just another way to illustrate all these things.
Yeah, the thing simply is like I think before I actually tried to convince like a data team to do this, and they were like, no way, this was like, it's impossible, it's like too hard, and we don't see the benefits. And I was like, yeah, but that's like, they're so tangible. You can like, it's so obvious you should do this. So I was like, damn it, we simply need to get more people to use this. And I think the best way is to show them through the simplest examples possible. So that's why I try to put something out there where there previously is almost nothing. At least I couldn't find it.
Yeah. No, that's a great. I don't come across any other examples. There's a few blog posts, maybe a talk here and there, but no concrete examples that kind of really illustrate these concepts. Any plans to extend it? To add to the repo more examples?
So I'm I'm preparing a talk on functional data engineering. I'm not. And the repo has a bunch of to-dos still, but the hard part actually is since data stacks are kind of like these little snowflakes, like so extremely unique. Even with these simple examples, I'm in the example I'm like taking is CSVs and just using plain Python. Obviously, everyone's going to tell me, yeah, but this works in plain Python and CSVs, but this is not any like data stack. So like going the next mile is actually a pretty big step. So I'm not yet sure how to do that. I'm still waiting for Maxime to publish something about the DBT version of it.
Yeah, it's been a while. He needs to do something, right? He needs to hold up his end of the functional data engineering.
Well, like besides building like a company, yeah, he needs to do something.
Yeah. Oh, there's that minor detail that he's doing, right? Do you have any? I know we've certainly covered a number of like different posts from Maxine. You know, I mentioned your repo that I think is quite effective. Is there any other recommendations to the listeners or the viewers?
Yes. Okay, so since there's so few stuff out there, of course, with a caveat, I would definitely recommend Infrastructure as Code by Keif Morris. So, you know, I think it's Keif Morris's book about infrastructure as code. And because he takes up so many of these ideas, like reproducibility, disposability, and so on and so forth, and discusses them, you know, at a different kind of level. A level that is still important for data teams, though. You know, he's kind of like, he would like zoom out to the, I don't know, like how do you make your business intelligence system reproducible and disposable, or like your database reproducible and disposable, or like your data orchestrator reproducible and, you know, like disposable. So
interesting.
But, you know, yeah, but to get like into the whole mindset of like how would I apply these things, this is a pretty good approach. And besides, at that level, it actually is a little bit, in my opinion, it's a little bit harder than, you know, to like zoom down to the partition level or like table level that Maxime uses. So yeah, at least you got like lots and lots and lots of content there.
Yeah, no, that's interesting. I'm going to have to check that out. Yeah, there's some of these. Yeah, I'm a big believer in IAC, but I think that yeah, I'm curious to know some of these how some of these functional concepts relate to that. So yeah, I'll dig up that. You said it was a book. Is that correct?
Yeah, Infrastructure as Code by Keif Morris.
Yeah.
Yeah, that's actually, you know, the how I kind of, you know, when I started out as a data engineer, the team I joined was actually picking up lots of ideas which were very similar to what I later realized Maxime has been publishing roughly around the same time. But we were coming from a very different perspective. We were actually coming from the microservices and like infrastructure as code perspective. Where we, you know, because that would also teach you to like have like immutability across all your data. So we were actually building like an immutable data lake. And, you know, having like a data warehouse which we could reproduce on the click of a button from, you know, the immutable data lake. So we actually had a very different idea, like very different approach, you know, like accumulating in this
different
workload, similar ideas.
Same approach, yeah.
Yeah, exactly. We just changed, you know, like the whole kind of perspective, I think. Yeah.
Yeah. Well, Sven, thank you so much for all what you do for the community. Again,
my pleasure.
You know, you're a great follow on Twitter, the posts, the newsletters. I don't know how you do it, but please keep on doing it. Thanks for coming on today. It was an absolute pleasure.
Yeah, I really enjoyed the conversation. So thanks for having me.